All right, we are actually going to use some of the properties of rhombuses, or rhombi, whichever you prefer, to find some angle measures. So the important properties, oh my gosh, that was interesting. Let's undo that. The important properties of a rhombus are, in case you forgot, the diagonals are perpendicular, which is going to be helpful to us. And the diagonals also bisect the opposite angles, which is going to be helpful to us also. Okay. So those are the two big ones that we're going to need. So let's just start. Let's look at this first one. We want to find all of the missing angles. So we want to find angle 1, 2, 3, and 4. Well, 4 is the place where the diagonals cross. So that's a right angle. So angle 4 is 90 degrees. And that means all the other angles in that corner around 4 are also 90 degrees, which is going to be helpful in a second. So there's angle 4. 2 and 3 are going to be the same because of this property about the diagonal bisecting the angles. So whatever angle 2 is, angle 3 is the same. Since a rhombus is a special kind of parallelogram, the opposite angles are equal. So this whole angle and that whole angle are going to be the same. And since it's a rhombus and the diagonals are bisected, like this property says, that means this angle 2 and the 68 match up. So angle 2 is going to be 68 degrees. And we just said that whatever angle 2 is, angle 3 is the same because this whole angle gets bisected. So that means angle 3 is also 68 degrees. And then we can find out angle 1 without too much trouble, hopefully. Because we know that this is a right angle and angle 2 is 68. And so what you have is a right triangle with a right angle in the corner, a 68 down here, and angle 1 is that one at the top. So get your calculator out and figure out what 180, because all the triangles in the world added to 180, 180 minus the 90 that's in that box right there, and the 68 is, that's 22, so angle 1 is 22 degrees. And there's all the missing angles in that rhombus. Okay, now let's look at the second one. And actually, I'm going to move these. Oh man, maybe not. Hold on. That said angle 4 equals 90 degrees. Okay. All right, we're just going to leave that the way it is then, because my computer's being wonky. Okay. Now look over here at this guy. Same deal. The place where the diagonals cross, that's angle 2, that's a right angle. So all these little guys are right angles also. So angle 2 is going to be 90 degrees. This angle down here at the bottom, because it's a rhombus, gets bisected. So if the left-ish part of the angle is 49, the top part is going to be also. That means angle 4 is 49 degrees. And then this little triangle right here that I'm about to outline in blue, triangles have to add up to 180. And you know a right angle, and you know 49. So take 180, subtract the 90 and the 49. So that's going to tell you angle 1 up here at the top is 41 degrees. And since a rhombus is a special kind of parallelogram, the opposite angles, like this angle at the top and that angle at the bottom, those are equal. So angle 1 and angle 3 are the same. So that means angle 3 is also 41 degrees.